Okay, so this video is going to walk us through this problem where we ended class last time. And the problem is shown here where really we're asked if we consider a 250 gram block of ice starting at negative 12 degrees, and we were to increase the temperature of this block of ice until it was 24 degrees, how much energy does that take? And the question, as you can see, is broken down into multiple parts. We can ask the same question. I'm going to scroll back up on the worksheet. And really, we're saying, if we remember, we're starting here and negative 12 degrees, and we want to warm that block of ice until it gets to about 24 degrees. So we're going to here on the curve. So we need to go through 3 steps. We need to calculate how much heat it takes to warm the solid to the melting point. Then we need to calculate how much heat it takes to melt that ice into liquid. And then we need to calculate how much heat it takes to warm that liquid until it's at negative 24 degrees. So we have 3 parts, 1, 2, 3. And then we can add those 3 parts together to get the total amount of energy it takes to warm this piece of ice. So I'll scroll down here to our problem. We can go through this one together. So again, we'll start with this part A. And we're given the heat capacity of ice, and we're told how much energy does it take to warm the ice to 0 degrees. So this was that step 1 of our problem. So in order to answer this, we're going to use our equation Q equals mc delta T. And we're solving for Q. So we're going to have Q is equal to our M, so that's the mass of ice that we have present, and we're told it's a 250 gram block, so 250 grams, multiplied by the heat capacity of the ice, so that's given in our problem as 2.029 joules per gram degrees Celsius. And then we will multiply by our change in temperature. And so remember, the change in temperature is always going to be final minus initial. So if we want, we can put that over here. Our delta T is going to be the final temperature, which is 0 degrees Celsius, minus the initial temperature, which was a negative 12 degrees Celsius. So delta T overall is 12 degrees Celsius. So 12 degrees Celsius. We can watch our units and see that grams are going to cross out, degrees Celsius are going to be crossed out, and we're going to be left with joules. So we get Q equals, and when I calculated that, I got 6087 joules. So that is the amount of energy it takes to warm that piece of ice, which hopefully makes sense. That is a positive number, and it should be a positive number because we have to put in energy to warm that piece of ice. So in part B, we're now asked how much energy does it take to melt the ice, to turn that block of ice from a solid to a liquid. And to answer this, we're given some information, most notably the heat of fusion for water is 6.01 kilojoules per mole. So what that is telling us is that's the amount of energy it takes to melt a mole of ice. Right? But we don't have a mole of ice, we have 250 grams of ice. So the first thing we're going to have to do is convert grams to moles. So let's go ahead and do that. We say 250 grams. We're going to divide by our molar mass of water, 18.02 grams for every 1 mole. And if you divide that out, when I did it, we got 13.87 moles of water. So now again, we know the heat of fusion is 6.01 kilojoules of energy per every mole. So if we had 1 mole of ice, we'd have to put in 6.01 kilojoules of energy. If we had 2 moles of ice, we'd have to put in 12.02 kilojoules of energy. But we have 13.87 moles of water. So we're going to take that 13.87 moles, and we're going to multiply that by the 6.01. 6.01 kilojoules, that's the amount of energy for every 1 mole. And now we can see our moles are going to cross off, and we're going to be left with, watch your units now, kilojoules of energy. So I got 83.4 kilojoules of energy. So you can see it takes a lot more energy to melt the ice than it did to warm that piece of ice 12 degrees. So the last step is now to calculate the amount of energy it takes to warm that now liquid water, that 250 grams of liquid water, from 0 degrees to 24 degrees. So to answer this question, we're going back to our Q equals mc delta T. We know we're solving for Q. The mass is still 250 grams. Now, C, we're given in the problem, is 4.184, so 4.184 joules per gram times degrees Celsius. And then the last thing is we need our delta T. So again, we can calculate delta T, final minus initial. So in this case, we're going to 24 degrees. We started at 0 degrees. So delta T is 24 degrees Celsius. So now we can plug that in, 24 degrees Celsius. We can multiply this out. Notice again, our units will cross off. Grams go away, degrees Celsius go away, left with joules. So when I did this, I got 25,104 joules of energy. I have not yet rounded to the correct number of sig figs. We'll do that in the final part, part D. And so part D now says, how much energy in total does it take to raise the temperature of that piece of ice from -12 to 24? So this is now the sum of our 3 steps. So the total amount of energy is going to take, we're going to have to add our 3 values. So we're going to now add together the 687 joules plus the 83 kilojoules plus the 25,000 joules. Watching out for units, I'm going to convert everything into kilojoules. And so I'm going to say this is going to end up being, start with that first part. All right, 6,087 joules, right? I'm going to now round that and say 6.09 kilojoules to go to 3 sig figs, plus the 83.4 kilojoules. All right, so this is the answer from part A, this is the answer from part B, plus our answer from part C, in kilojoules, 25.1 kilojoules, and our final answer to 3 sig figs will now be 115 kilojoules. Thank you.